Hey everyone, welcome to our class ED 710. This is the summer term. Really excited to be teaching you this summer. Look forward to meeting together in person soon. This serves as a video introduction to the course. This is the outline of what I'll be doing today. We'll go over a little bit of intro for the course. I'll review the syllabus briefly, talk about why I think every human on the planet should learn statistics. I have an extended example, which will give you a preview of where we're headed and serve as a conceptual backdrop for the whole course. And then at the end, I'll have a gentle introduction to Stata. All right, so I know you're required to be here, and we all have mixed feelings about being here that maybe fall into these four categories. In the A category here, this is from Up at the beginning when his wife has passed away and he's just feeling very sad. So are you sad to be in this class? B, this is from the movie Psycho. Are you very terrified of what's coming and you're just so nervous about this class and want to get it done in summer one to just finish it? C, are you more nervous for being here? This is Molly Shannon, right? When she gets nervous. Or D, are you really happy? And this is Mr. Little Jeans from Rushmore at the end of the play, who's just ecstatic. So we might have, it's just to remind you, we're all coming to this space feeling different feelings as we enter into statistics. All right, I invite you to review the syllabus. My objective, my goal for this course is to help give you a way of thinking and interpreting statistics in educational contexts. So you can read about it. My approach is very much applied. It's not focused too heavy on the math. It's focused more on the application, that you understand the rationale and the thinking and the intuition that comes with the study of statistics in educational contexts. The book that I have is Introduction to the Practice of Statistics. I have the 6th edition, which I know is woefully outdated, but that's okay. Any edition you can find, grab that. It hasn't changed very much. Statistics, the way I'm going to teach it, is very translatable across time. It doesn't change too much. So any of these editions should work. I want you to be here. I want you to attend to the extent possible. I know it's the summer term. Again, the structure of this course will be you'll watch videos, 2 videos of me doing something like this with slides. So you'll watch the video content. That'll be reserved for that Monday class session from 4:30 to 8:30, but we do that asynchronously. You can do it whenever you want. And then Wednesdays, we will meet together in Caldwell Hall for those who can make it, because we'll be doing some applied work in Stata, and it's just important to have the program and for me to be able to be there to help you with that application. So that'll be the course. We'll meet together in person. I'll have a Zoom option for those who can't make it on particular days, but invite you to be in person as much as possible on those Wednesdays. We'll have these synchronous activities that will help you learn these concepts. We'll have quizzes that will come during class as well, and we'll have 4 problem sets I'll go over in a second. There will be a final that will be taken asynchronously. It'll be due at the end of the term, and you can, of course, review our Moodle site. I believe it goes live tomorrow on the 15th, and we'll work with the college to make sure that you have Stata and all the resources you need there. You can review these due dates. They starting at the end of the month. We'll have your first problem set due, and then they come every week. I like them due before class so I can look and summarize quickly how you did on those for the time when we are together in person. So those are due. You have those due dates. And then again, the in-class final exam will go live after our review session, and then will be due at midnight on the 21st. This is a really important slide to form the foundation of your conceptual understanding of statistics. There are 2 main branches that we talk about. There are descriptive statistics, and it may be that which you're most familiar with coming into this course. This is just organizing, summarizing, and displaying data. So the tables that you see presented to you, we can see it in the news or in other outlets, in the papers you're reading. There are tables, there's charts, graphics. We have what we'll talk about measures of central tendency, like means or averages, median, mode. And then there's measures of variation or measures of spread, like standard deviation, variance, and range. All of that is very descriptive in nature. The second part or branch of statistics is inferential statistics. And what this involves is using sample data to make inferences about a population from which that sample was drawn. And in our class, we're going to be talking about a few statistical tests, inferential statistical tests that we'll use, including correlation, t-tests, ANOVA, and regression. I'll have an extended example that talks about those. But the whole idea here is we want to make inferences about a population, but to do so, we draw from a sample. And so necessarily, there'll be some degree of estimation that occurs. There'll be each estimation or each statistic that we're going to calculate will have some degree of error around it because we are making an inference and we don't know exactly what's out there that's true. And so that will be the branch of statistics we call inferential statistics. Building from those two branches, here is the overview of topics that we're going to cover in this course. We'll talk about describing distributions and data visualizations in the first two lectures, and that aligns with descriptive statistics. And then to form the foundation for inferential statistics, we'll talk about probability and randomness, this idea of hypothesis testing, inference, and statistical significance. And then finally, we're going to learn a series of statistical tests, starting with the one sample z-test, moving to independent and dependent samples t-tests, ANOVA, chi-square, correlation, and at the end, we'll do a little bit of linear regression, which will prepare you for Quant 2. Let's start by asking a question you may be asking yourself right now, which is, what is the point of learning statistics? Well, the first thing statistics does is it helps us to summarize large quantities of data. As an example, think of the NFL's passer rating. This rating's calculated using passing attempts, completions, yards, touchdowns, and interceptions. So we take those 5 indicators of a QB's measures of what the quarterback did during a game, and we collapse them down into a single rating that tells us how well that quarterback did. So take it just a minute and ask yourself, what are the strengths of this rating and what are the weaknesses? Well, the strengths is it provides meaningful information in an easily accessible way, and it allows for a quick comparison between quarterbacks. So we can know across any games on any given weekend how well quarterbacks did based on this QBR. But of course, it doesn't account for all the information, and it can miss important information, other factors that influence the outcome. For example, how often the ball is dropped by a receiver, or weather conditions, or there are lots of other variables that might affect how well a quarterback's done, injuries that they might have, things like that, that additional statistics could account for and create a more robust measure. So it has some strengths, but it has some weaknesses. The strengths being it collapses lots of information, the weaknesses being it doesn't account for everything. So I want you to just brainstorm quickly with yourself, what might be an example from education where we're collapsing a lot of information or summarizing a lot of information. All right, number 2, statistics can help us make better decisions. This particular statistical thinking. Now, I'm from Reno, Nevada, so grew up around cards and casinos, so you'll have to forgive me there, just nature of my birth and being raised. But let's imagine you're playing Texas Hold'em and thinking about probability here. So let's say the person next to you bets $10 and the pot now becomes $100, okay? So you need to pay $10 to receive the next card, and you're sitting on this hand. And if you don't play the game, that's okay. Essentially, with this hand, we want to know what are the odds that the next card down and the last card that'll be played here for the cards, whether it'll be a heart. Because if it is, then we'll get a flush and we have high probability of winning. And I should say, pause the video. And for those of you who want to, go ahead and try to calculate what are those odds. All right, so here's a process that you might go through to calculate those odds. The first, you have to say, well, how many hearts are left? Well, I know that there are 4 out. I have 2, and there are 2 on the table. So there are 13 total hearts in a deck of cards, and I have 4. So we know there are 9 hearts. How many non-hearts are left? Well, we have the number of non-heart cards are 13 per suit times 3, so 39. But the non-heart cards that are on the table are 2, so that gets you to 37. And then finally, so what are these odds? The odds are just going to be these 2 ratios of 9 to 37, or about 0.24. Okay, so that's hearts divided by non-hearts. The idea is that I have essentially a 1 in 4 chance, a little less than a 1 in 4 chance, that next card will be a heart and I'll win. So what do? We have to pay $10, or a 1 in 4 shot, we could win the pot. Most people would fold. It's just not a high enough probability. Now stay with me. An expert, however, understands that there's another variable that's at play here, and that is the bet and the opportunity to play this game lots of times. Okay, so if the pot's $100 and you only need to pay $10 to play, that means for every dollar you spend, you could earn, your return could be $10, or the pot odds are 10 to 1. For a dollar I pay, I could get 10 back. So now what statistics invites us to do is say, what if you confront this situation 100 times? How many times would you expect to win? Well, we know we would win just based on probability about 24 times. But let's be conservative and round down and say, okay, if I were to play this 100 times, I would win at least 20 times. All right, the final calculation here. If I were to play this scenario 100 times and I won 20 times, let's say I'd make $2,000, right? Because each time I'm winning $100, I win 20 times. But what do I have to pay? Well, I only have to pay $1,000 in, right? Because it's 10 times for each time I play this scenario by 100 times. So my profits are $1,000. So anyone who thinks in statistical language, thinks about these probabilities, would bet, even though it was a probability of 0.24, knowing the odds, the return on the pot odds, an expert would go ahead and bet that $10, knowing that in the long run, if they were to continue making those rational, consistent decisions, you're going to make $1,000. All right. Before you race off to casinos, we have other reasons why statistics can help us make better decisions. That this practical one, where should I eat? There's this excellent visualization. It's posted here. You can click on it when you have the presentation. But it talks about restaurant chaininess. And wherever you go in the United States, they've mapped, based on Yelp reviews and based on who owns restaurants, the degree to which a restaurant is more like a chain or more ma and pa, more locally owned. And this map was born out of COVID when we were trying to support locally owned restaurants to keep them afloat during this time. And so if you like that, if you're traveling or you like chains, right, whichever way it goes, this map could help you make a better decision. And we know underlying it are a lot of statistics, a lot of information that's being aggregated to produce a simple map like this one that helps us to make a more informed decision about where we should eat tonight. So what does this mean for me? On a personal note, growing to know and understand statistics has helped me to think about long run outcomes. It's helped me to think about this idea of random chance versus real change. And that's really a critical one that we'll talk about as we think about whether or not what we do matters. So if we have some reading intervention that we're interested in implementing in our school, and it seems like kids' test scores get a little better after I do the intervention, we want to know, was that difference due to chance, or was there actually something systematic that went on that the kids' growth was actually real? And statistics will help us to better understand whether or not some change is due to chance alone, or whether we think with a high degree of confidence that there was something else going on there. And honestly, it's just helped me withhold judgment, because when I interact with my kids, for example, I have 3 kids, and it's just a bad day for one of my children. Let's say Esther's just having a bad day. I know that in the long run, when I think about it, it's like, this is just a small moment of a day, and it's just a small part of that day for her. And she's just having a tough time. Or maybe I'm having a tough time, and the way in which I'm interacting with her is a bad look, right? And so we can, I don't know, statistics just help me think about that idea of like, look, like in the long run, what's the long run trajectory of who I am and who I'm becoming and the type of person I am and my kids? So there may be these wiggles that are happening when they're little. There's these big dramatic swings in their behavior. But as they get older, I have a high schooler now. She's, her kind of mood swings are definitely starting to flatten out a little bit, though it depends, right? Depends on the week. But in the long run, she's becoming an incredible woman. And it's like awesome to see her become that. And so it's helped me just think in that idea of long-term, long run, and withholding judgment. As a master's student, I studied international education policy, and I really grew to love how statistics can help us answer and address a range of social issues, from health and poverty, education, criminal justice, lots of things. Here we have an example of extreme poverty from the World Poverty Clock. You can click on this, go to this website, and it'll show you by second how many individuals are either falling in or escaping, coming out of poverty. And then it has indicators for country, and you can see how many 627.3 million people are currently still living in extreme poverty, and you can get a definition there. But this is statistics, right? This visualization, and if you go there, you'll actually see little figures running across the screen, either falling into poverty or escaping poverty. And it's this idea that you get a sense of how statistics can be visualized in a way that helps us advocate for change. When you have some time, I know there are lots of TED Talks out there. This is a fun one from some researchers from Cal. That's main research focus lab was around this idea of like, are rich people worse people? Are they more likely to lie, steal, and cheat? And often the answer is yes. And so there are these controlled and natural experiments that they use to test this hypothesis. It's a really entertaining TED Talk, but it gives you a sense of how they use randomized environments and control trials and statistics to get a sense of this question of, are rich people worse people? Now, importantly, they'll at the end talk about how little interventions can help remind people and to not dehumanize, and to, just because you're wealthy doesn't mean that you shouldn't see other people as people. So it's not all bad news for rich people, but it's quite entertaining. Another reason to learn statistics is it can help us recognize patterns and change behavior. And there's this great principle from Super Freakonomics in this book, then you can hear the podcast around it, which is really interesting, called Weeding Your Own Garden, which is, how do you get individuals to reveal their preferences to you or to their true beliefs in strategic or clever ways? Or change behavior in particular ways. So in the title of this book, Why Suicide Bombers Should Buy Life Insurance, they just found that and all the variables they crunched in England, they found that one variable that was not predictive at all, like nobody buys life insurance from a bank. And so they said, if we put this in the title and we talk about you should buy life insurance if you're a suicide bomber, because suicide bombers just don't buy life insurance knowing that they're going to commit suicide. And so the whole idea was, let's see if after the book comes out, anyone that has other markers of potentially being radicalized goes out and buys life insurance from their bank. They're like revealing themselves to potentially be terrorist. And so that was the idea here. Like, can you reveal people? Or David Lee Roth used to ask their set list that there were no brown M&Ms in his M&M bowl. And the idea was not that it's like, I don't like brown M&Ms. The idea was, if individuals that are setting up for our shows that has a lot of mechanical parts and things that could be very dangerous, like to know whether or not we're set up well, we want to know that they read everything. And if they read everything and pulled out the brown M&Ms, it means they were very careful in setting up for our shows and we can trust them. But if we get there and the M&M bowl has brown M&Ms, it means they didn't read the set list. And it means we probably need to go double check everything so we don't get injured. And that's the idea. How do you get people to reveal their preferences or change their behavior? It's the NBA playoffs right now. So if you're an NBA guy, which I enjoy watching it, the NBA learned recently through analytics that 3 points is greater than 2 points. Or the idea being, when they started to map shot selection, they realized that how many points do you make per shot from certain areas, that like Michael Jordan's bread and butter, that mid-range jumper, and Kobe's, that's not the most efficient shot. In fact, you make under 0.85 points per shot there. Whereas if you go outside the arc, you get over a point on average. So that's why these NBA teams are spreading the floor more, they're shooting more threes, or they're dunking, right? Or it's the lob dunk, or it's something, the dribble penetration, get a hoop, get close to the rim, because those are the areas the maps are telling you are going to yield the greatest number of points. So all that analytics, all the shot selection over time that they're gathering, they're starting to realize, oh, and that's why the game's changed so much. Okay, getting to a more serious topic. Statistics can help us evaluate the effectiveness of policies, programs, drugs, medical procedures, etc. Educational interventions, it runs the gamut. And so, for example, in providing aid to the poor throughout the world, there's a big debate of whether or not we should charge user fees or should we just give things out for free. Because on the one hand, charging a fee encourages use and it prevents these resources from being wasted. So the often example they show is like malaria nets being used for fishing, not for keeping, the mosquitoes out. And it may discourage dependence on free handouts. Okay. On the other hand, the poor may not be able to afford the fee, however nominal it is. And so they won't be able to get to the resource because they can't afford it. Researchers then have said, well, let's test it, right? Let's use randomized control trials where we randomly assign individuals to do one thing or the other and figure out what price sensitivities there are. Okay, so due to chance alone, we're going to randomly assign individuals to do one of several clinical interventions. All right, you could take a moment here, but here are a list of featured evaluations, who conducted the study, where they did it, the price points they tested, anywhere from free to what they charged, and then the approximate market priced in that area. And you can see this is everything from deworming medicine to bed nets, disinfectant, hand washing soap, school uniforms, and you can see their relative cost. All right, so here we have plotted for you the results from these different interventions, from the deworming, the bed nets, the disinfectant, and the soap. What you'll notice on the y-axis here is the percentage take up. All right, how many people are using that service? And on the x-axis is the price, free being at the origin here, and then moving out towards $1. And you can see that there are small fees. It's very price sensitive. The slope, the steepness in which these are decreasing show you that there is a lot of price sensitivity here, where if we just start to charge a little bit of a fee, the take up shoots way down. The percent of individuals that are taking advantage of that service go down. So these are important data as we think about the sensitivity around prices for those living in poverty. Notice here now from these bar charts, the effect of pain on usage. Notice that these are pretty comparable. The idea is that fees, that positive price, that lighter blue, don't substantially promote use. So in the first case, it's actually a little bit lower. And then you could see the others, they're almost roughly equivalent. Here, water disinfectant in Zambia after 2 weeks, those who were charged price, it was higher, 55% compared to 46. But the idea being that it doesn't seem like there's a big gain here by promoting, by having a fee. Three other findings from this research. Importantly, cost sharing, that is passing the cost on to the poor, fails to target those most in need of the product or the service. So, for example, a family with young children is less likely to pay for chlorine to prevent diarrhea or bed nets for their children. 4, also importantly, there are no negative long-term effects of free distribution. In fact, learning about the benefits of a product by using it because you received it for free may actually make you more willing to pay for it, they found in studies, in the future. So you get the bed net for free. Once it wears out, you're now willing to pay because you saw the difference that it had in your life. And so the question really becomes why? Like, why this price sensitivity? Well, often there's just a lack of cash on hand. People just really don't have the money, however nominal that fee is. There's this inconvenience associated with traveling for a certain service. And the fact that you have to deliberate in family with a partner or with someone really deters that purchase. Therefore, what? What do we learn from this set of research studies? Well, when should we distribute for free? This, I always like, a policy researcher. What are the implications here? When should we distribute these for free? Well, when the benefit extends beyond the immediate user, that's an important reason to do it. When the product and services are aimed mainly at preventative behavior, also important. And finally, when the product is very cost effective, like the examples that I gave you. All right, we've been a lot of places. We've talked about the NBA. We've talked about bed nets and deworming. We've ran the gamut here, but the whole idea is that statistics can help us summarize data, can help us make better decisions, can help us answer important social questions. It can help us recognize patterns and change behavior, and it can help us evaluate the effectiveness of policies, programs, drugs, medical procedures, etc. All right, in short, from Charles Whelan, statistics is the most powerful tool we have for using information to some meaningful end. And with the rise of big data, statisticians will have, quote, the most sexy job over the next decade. That's from Hal Varlan, the chief economist at Google. But in short, statistics really does have a powerful influence over the way in which we understand and make sense of the world, and can work to help us make that world better. So I alluded to this at the beginning, but this is my approach. While statistics relies on numbers and formulas, it's the logic behind statistical methods that often proves to be the key to success or failure. So while you can memorize formulas, if you don't really understand the logic and intuition behind the formulas, it's impossible to understand what statistics is all about. So my approach is going to focus on the reasoning and logic behind the methods, as well as provide you with a lot of examples and opportunities to practice, quote unquote, doing statistics. And again, my goal will be interpretation and analysis over memorization. You, as doc students, are charged with producing original research, and that research may include statistics. For this course, you need to begin to be knowledgeable consumers of educational research. So I'm going to teach you on that idea of how to know what to use and how can you tell what somebody else is doing, whether or not it's appropriate or not. Now I want to transition to an extended example that's going to help us give a map of where we're headed. So all of the things you're going to learn across this course, I'm going to try to summarize with this extended example of some best-selling books. Here are 12 of the best-selling books of all time. And I want you to take a minute and just estimate the number of books you think have been sold for each one of these. So individually, you might write down a guess for each book. And if we were together as a class, we could record all those guesses. And once I have all that information, we could calculate an average guess for each book. How many do we think on average each book has? We could also think about the variation between the students, all of us, within each book. So each book would have some average guess, but there's going to be some spread. Some people might say 5 million copies and some might say 30 million copies, right? So we're going to have some degree of variation that helps us think about how many books have been sold, what our guesses are. All right, well, these numbers, they're probably a little outdated. I didn't update the numbers. So this is, 2019, 2020. But here's the order. And notice I've organized it in this bar chart of books sold in millions. So that's what you have on the y-axis here. And we've gone from the smallest to the largest for these best-selling books. So Life of Pi is at 10 million. And then you go all the way up to The Lord of the Rings, which is at 150 million copies. All right, so these are the actual numbers. So what we could then do is compare what our guess was, like the descriptive statistics we calculated, with the actual numbers. And notice how here, just foreshadowing where we're headed, we had some descriptive statistics. Now we have a visual. We're learning about data visualization to know what's the best way to show that. Now, let's suppose we were interested in polling people's opinions about these bestsellers. Well, we might want to use a survey. And so we'll talk a little bit about survey research. Again, I'm outlining the course where we're headed, where we might ask questions. We could decide what kind of questions are we interested? What do we want to measure? How could we ask questions in a way that would reliably measure the constructs that we're after, or these ideas that are out there in the world? So we might want to measure why certain themes resonated in these books, what themes might connect. And so we have questions we design around that. And then the question for us is, how could we do this reliably? And then how would we know that our results are valid? So we'll talk about reliability and validity as it relates to a brief introduction to survey research. Okay, now we're going to transition to a series of statistical tests. And I'm going to use the same example to help you get a sense of the intuition, the idea behind how we use these tests. Okay, the first statistical test is called the one sample z-test. That is, we want to compare the average number of books sold across our 20 books to the average number of books sold in the population of bestsellers. Okay, so I picked these 12. But how does that average compare to the whole population from which these bestsellers were drawn? Okay, that's when we want to use a one sample z-test. We want to know, is there a meaningful difference between my sample and the population from which that sample was drawn? So we might ask a question of, well, how could we use this test in education? What might be an example? Well, maybe I want to know if my school's achievement, for example, or my school's climate is different than the states, the population of schools from which my school is one. Okay, so you get that sense of we're comparing our sample to the population. That's a one sample z-test. And the comparison is some measure that we're interested in that's quantitative. It needs to be a quantitative measure where we can get a mean. We need to compare these means between the population and our sample. And the whole question is there a meaningful, not a difference due to chance, but is there a meaningful difference between those two? Then we use the one sample z-test. All right, let's go to another example. Let's say from our 12 bestsellers, we were interested in comparing the number of copies sold before and after 1965. All right, so we picked that year because that divides them 6 and 6. So we have 6 of our bestsellers before 1965 and 6 after. And the question for us is there a meaningful difference, not a difference due to chance, but is there a meaningful difference between the number of copies sold before and after 1965? All right, and to do that, we would use an independent samples t-test because these books are independent of each other. These 6 are different than the other 6. So the question for us is, well, how might we apply that in education? Well, anytime we have 2 independent groups, we can compare them on a quantitative outcome in which we can calculate a mean. For example, multilingual learners. We could compare the reading achievement or math test scores or attendance of multilingual learners compared to those who are non-multilingual learners. And the question for us would be, is there a significant difference, a meaningful difference between their outcome based on being a multilingual learner or not? And the key here is independence. We can't have any individuals that are in both groups. For example, a multilingual learner and not a multilingual learner. They have to be independent of each other. And that's when we use this t-test. And it tells us whether or not there is a statistical or a meaningful difference between 2 independent groups. All right, a different way to think about this would be, what if for our subsample of bestsellers, 11 of these books have been made into a movie? And we're interested in comparing the number of books sold before the movie came out to the number of books sold after the movie came out. We just want to see if the movie induces additional, more copies being sold. So the question could be, we could use what's called a dependent samples t-test, because notice the books are the same before and after the movie release, but we're comparing it from before the release to after the release. So there's the dependency that's been created, but we have 2 outcomes. We have the average number of books sold before compared with the average number of books sold after. Okay, those are the 2 means. So we can do the same thing. Is there a meaningful difference between these 2 means? How can we use this in education? Well, the most straightforward example would be, for all of us that have taught, a pre-test and a post-test with the same individuals taking the exam can let us know, did they do better after the class compared from their pre-test to their post-test? That would let you compare those 2 means. And we can do this across any intervention that we're interested in studying in education that has this dependent samples, meaning you have the same individuals in the pre-test as the post, or the before period to the after period. Okay, well, up until this point, we've only compared the difference between a sample and a population, or 2 groups. But what happens if we have more than 2 groups? What if we want to compare the average number of books sold across countries of the authors? So we have, in this case, the United States, we have a Canadian author, and we have British authors. Okay, what do we use then? Well, we go to a test called the analysis of variance, or an ANOVA test, which is going to tell us if there's a meaningful difference somewhere between the outcomes of the average number of books sold in the US authors, Canadian authors, and British authors. Okay, so how do we use this in education? Well, anytime we have more than 2 groups, we can switch to an ANOVA to compare that the differences between those groups. And what the ANOVA test will tell us is that there is some difference. It doesn't tell us in its first calculation where that difference is. It just tells you if there's a difference somewhere between these groups. So how do we apply this? Well, it might be that we're interested in studying performance by students' race and ethnicity. And we have different categories of white students, African American or Black students, Hispanic students, Asian students, whatever it might be, those categories. And we can take them all on some outcome, like a test score, and we can compare whether or not there is some difference between those groups collectively. There are other tests that come after that that can tell you where the difference is. And essentially, it's kind of like conducting t-tests. But the idea being that ANOVA will tell you if there's a meaningful difference between more than 2 groups. All right, now let's revisit this subsample of books that have been made into movies. And let's say we're interested in knowing the relationship between movie revenue and the number of books sold. Is there some meaningful relationship? Now, in this case, notice the two variables we have. We have movie revenue, which is a number, and number of books sold, which is a number. And the idea is we can correlate, use a correlation test to see the degree to which those two numbers move or don't move together. That's a correlation. So how can we use this test in education? Well, anytime we have two quantitative numbers that we want to see how they relate to each other, and the great thing is they don't have to be on the same scale. We can be, for example, number of absences and math test scores. We can correlate those things and how they move together. We might have a hypothesis in mind, which is the more you're absent, the worse you're going to do in math. Okay? And a correlation will give us a number about how those two variables relate to each other and whether or not that relationship is different than zero or is meaningful. All right, hang with me. We're getting close. But another test, another question we might have is, what if we're interested in seeing if the number of books sold predicts how well the movie is going to do? Because, these 11 movies, they got made for a reason. People are reading the book. The question is, if they've sold more books, will it predict movie revenue, differences in movie revenue? This is where we would use linear regression. When you have a single variable, a predicting variable or an independent variable that's predicting this dependent variable of film revenue. Number of copies sold predicting film revenue and what that relationship is. So how can we use this test in education? Well, we can really use any variable. It could be categorical or it could be continuous. Let's just, for this example, say continuous, which could be, how does my beginning of year exam predict how well I'll do at the end of the year? Or how well does my GPA in high school or my SAT score predict how well I'll do in college, my college GPA, okay, or my GRE, something like that. So the idea is you can use variables that come before and see how they predict other variables, how they shape what relationship those two variables have with each other. And that we would use linear regression. Now you may be saying, okay, but like number of copies sold, that's not like the only thing that influences movie revenue, right? And so what multiple regression lets us do is add additional variables that might predict how well a movie does. So that could be when the movie's released, the time it's released during the year, what other movies are being released at that time, how many movies of that type have been made before, what's the cast, what was the budget they were given. All these other variables might contribute to how much film revenue we have. And what multiple regression allows us to do is add those other variables into the model to predict that outcome. So we have multiple predicting variables or multiple independent variables that are predicting that film revenue variable. So how do we use this test in education? Well, we use it all the time in lots of ways. Anytime we have an outcome that we're interested in, let's just take the classic one of students' test scores. We know that there are lots of variables that go into how well students do that include home life characteristics, students' backgrounds, as well as their educational context and experiences, both at the school district level, the school level, maybe the community level, as well as their teacher and their peers. And we could go on, right? And so multiple regression allows us to try to account for those variables and understand those relationships better. And again, with all of this, because it's inferential, we're trying to decide whether or not these differences or these effects or these relationships are meaningful or statistically significant, as we'll talk about. Okay, our last example we'll talk about is what's called the chi-square test. And that's when we have two categorical variables that we would like to understand their relationship to each other, okay? Categorical variables meaning they have a nominal level of measurement or ordinal, and we'll talk about what those mean, but the idea being is that There's categories, not continuous quantitative numbers. So in this example, we might say author sex, male, female in this case for these authors, and their nationality, USA International. And we want to know, is there some meaningful relationship between author sex and the author's nationality, whether it's USA or not? And we would run a chi-square test to understand that. So how could we use this test in education? Well, anytime we have these categorical variables that we're interested in, and often it's, for example, student opinions of school, how much they like school. Don't like school, school's okay, to school's awesome. Let's say it's those categories. And then we might look across demographic groups and say, well, based on your demographic, how do you feel about these categories of how great school is? If we have these three categories of not so great to awesome. Okay, so there are ways in which when you have these categorical variables that you would use a chi-square test. All right, importantly, the type of statistical test you choose to use will be determined by your research questions. That is the most important part, is what are you interested in learning? And if it's a quantitative paradigm that you're bringing and the research questions lend themselves, then your goal is to try to know which of all these tests should I use. I gave you this extended example to give you kind of an applied framework for thinking about it. But my goal will be at the end of this class, you'll have done this enough that you'll be like, oh, okay, in this situation, I'll want to use a t-test. Or in this situation, I should use regression or chi-square. Okay. And then importantly, what those tests give you. Do I know how to interpret it? Can I take what the results are from Stata? Can I interpret them and make sense of them and write them up in a way that other people can understand what you've done? And the key will be that you become more familiar as you do this, so that when you get into the research literature, you become more comfortable there. You become more comfortable understanding and interpreting what others have done. Now, if you're overwhelmed, that's okay. Like The Hitchhiker's Guide to the Galaxy says on its cover, don't panic. There's a lot that's been done in this area of statistics. You have me, we have TAs, you have your classmates, you have internet resources, the Khan Academy. As many resources as I can provide you that can help you try to be successful as you navigate this space. All right, that is the end of the lecture portion of today. I do want to provide you with a demonstration in Stata, an introduction, a gentle introduction to Stata to get your feet wet there, get us prepared for where we're headed. I'm going to do that in a different recording, so you'll just jump to my other video to watch that introduction.